Let's explore how to execute SAS SQL in SAS Viya Workbench. We'll use my workbench named Executing SQL. It uses 4 CPUs and 16 GB of RAM in the cloud environment and is tailored for my specific workloads. You can adjust these settings to meet your needs. I'll select Start to spin up the workbench. Within a few seconds, the workbench is ready. Once the workbench is initialized, I'll select Open Visual Studio Code. Then close the default window. In VS Code, I'll use the Explorer to navigate to the folder where I prepared the files, Executing SQL, and then sas_sql.sasnb. The .sasnb extension specifies a SAS notebook, which are like Jupyter notebooks. In SAS Viya Workbench, the SAS SQL procedure, known as procSQL, is the primary tool for executing SQL within SAS. If you're familiar with the SQL procedure, much of this will be a review for you, but you might even pick up a trick or two. For newcomers, the SQL procedure seamlessly integrates structured query language, or SQL, within SAS, enabling you to retrieve and manipulate data, create tables, views, and indexes, create SAS macro variables, prepare and explore data, and even send database-specific SQL to a database. For the upcoming examples, I'll simply focus on executing SQL on SAS tables without using a database. If you have access to a database, procSQL enables you to execute SAS SQL or native database SQL on the database. The SQL procedure resembles other ANSI SQL implementations, but it does offer some specific SAS enhancements. I'll cover a few of those here. In the first cell, I'll download the homeequity.csv file from the example datasets for the SAS Viya platform website, and then save the file in the Execute SQL folder in the Workbench cloud environment. If you are following along, you might have to change the path macro variable to specify where you want to save the file. In the cell, the first %let path equals statement specifies the cloud folder path. The %let CSV file equals statement specifies the URL of the CSV file. The file name statement specifies the file to create in Workbench, homeequity.sas.csv. The HTTP procedure sends a GET request and downloads the CSV file to the cloud environment. I'll run the code in the cell by pressing Shift and Enter. I'll navigate to the Explorer and refresh. Notice that the homeequity.sas.csv file was saved. Next, I'll create a SAS table named homeequity in the work library using the import procedure. The results show that 5,960 records were read in from the CSV file and the homeequity table was successfully created. To manually view the table in the SAS library, I'll select the SAS extension, and then expand the work library. The table now exists in work. Once data is stored in a library, referencing it is straightforward. Simply use the library name, followed by a dot, and then the table name. My first step is typically to preview the data. To do this, I specify the procSQL statement and then my query to view every column in 10 rows of data, followed by a semicolon to end the query and the quit statement to end the procedure. To view 10 rows in procSQL, you use the obs equals dataset option on the data referenced in the from clause. In other SQL implementations, you might use the limit clause or some other statement. I'll run the code. The results show 10 rows of the table. This table is a modified version of the common HMEQ table you might have seen before. In the SAS notebook, you can conveniently specify an SQL code cell, eliminating the need to write procSQL and quit statements repeatedly. Behind the scenes, it'll run procSQL for you. I'll leave the code cell as SQL and just run the query. The results are the same. To view the log to see what was executed, I can select the More Actions option, then Change Presentation, then the SAS log renderer. In the log, it shows that SAS enclosed my query with the SQL procedure. I'll change the presentation back to the SAS HTML renderer. Moving forward, I'll continue to use the SQL code cell. Let's execute another standard query to filter and sort data. I'll use the select clause to select the bad, mort due, value, reason, and job columns from the work.homeequity table. Filter for all rows using the where clause where bad equals 1, mort due and value is not null using the is not null operator, and job equals sales. Then I'll use the order by clause to order the results by mort due in descending order. I'll run the query. The query returns the expected results. You can also create a calculated column as you'd expect. Here, I'll take the same query as before, but create a new column that subtracts mort due from value and names the calculated column value_diff. The where clause remains the same, and I'll order by the value diff column in ascending order. The results show that the new column was created and ordered in ascending order. Now, filtering a calculated column with SAS SQL can be a bit different. First, let's filter the calculated column the traditional way. I'll add the expression to the where clause and filter the calculated column for all values less than 0, reusing the calculated expression from the select clause. Notice that the results show 4 rows have a negative value for value_diff. However, ProcSQL includes the calculated keyword enhancement. The calculated keyword refers to columns already calculated in the select clause. This is very useful when the calculated column expression is complex. For example, in the same query as the previous cell, I simply replace the calculation in the where clause with the calculated keyword, then the calculated column name value_diff from the select clause. I'll run the code. The results show the same 4 rows. I like using the calculated keyword because I don't have to retype my calculation. I can simply just reference the new calculated column name from the select clause. In ProcSQL, you can continue to use the group by clause for your aggregations. For example, let's calculate the total mort due amount by region. The sum function will calculate the total mort due, mortgage due, by each region. I'll name the new column total_mort due. The results show the aggregated data. Notice that the south region is in scientific notation. What if we want to display the entire aggregated value as currency? SAS provides a wide array of formats you can use to display values in the output. To use a format, simply add the format equals option to the column in the select clause and specify the SAS format. In this example, I'll add the $18.2 format. The dollar format writes numeric values with a leading $sign, a comma that separates every 3 digits, and a period that separates the decimal fraction. The 18 specifies the entire width of the format, including symbols, and the 2 specifies the number of decimals to display. I'll run the query. Notice that the results are now displayed as currency. You can check out the SAS documentation for a list of available formats. Another common task is to count the number of missing values in your columns. For example, to count the number of missing values in the bad, mort due, and value columns, I'll use the sum function with a case expression. The case expression will check for a null value using the missing function. When the value is missing, add 1, otherwise a 0. Then, the sum function will aggregate the values for each of those columns. I'll execute the query. The results show the bad column doesn't have any missing values, but the mort due and value columns do. For most SQL users, joins are extremely common. Let's do a very simple inner join. I'll start by creating a simple lookup table using SAS code. Notice that my cell language mode is SAS. I'll run the code to create and view the table. The table has 2 columns, loan_value and bad. I'll join the bad column with my main home equity table to obtain the values paid and default for each row. This is a simple join for demonstration purposes. I could have used a case expression for such a simple lookup. Next, I'll perform the join. I'll select all rows from the home equity table, subsetting for only 10 rows as a sample, and perform an inner join with the bad_lookup table. I'll join the tables on the bad column. I'll select all columns from the home equity table with the alias HE, a dot, and the asterisk, and just the loan_value column from the bad lookup table. Notice that in the results, the column loan_value was added, and we can clearly see the values paid or default. Lastly, let's perform some data engineering and create a final table. In the final table, I'll add SAS formats and labels to the columns, I'll create new calculated columns, and I'll replace missing values in the mort due and value columns with the mean values. To achieve this task, I'll begin by calculating the mean values of mort due and value columns and save them into macro variables. This can be easily accomplished using the SQL procedure along with the into clause. This feature is a SAS enhancement. I'll create a query to compute the mean of mort due and value, followed by rounding the mean values. Then, I'll use the into clause to store these values into the macro variables avg_mort due and avg_value. Additionally, I'll add the trimmed option to eliminate any leading or trailing spaces in the macro variables. The result of the query shows the average value in the avg_mort due and avg_value columns. Afterwards, I'll utilize a SAS code cell to display the values of the macro variables avg_mort due and avg_value in the log using the %put statement. The log shows that the average values were stored successfully. Then, I'll use the create table statement to create the final table, home equity final. I won't go into details of every part of the query. First, I've added the format equals and label equal option to the columns to format and label columns accordingly. SAS labels enable you to add descriptive labels to columns, but the original column name is unchanged. The two case expressions will replace all missing values in the mort due and value columns using the macro variables created earlier. When the column is missing, then use the value stored in the macro variable. Otherwise, return the original numeric value. I'm also using a few SAS functions to clean some of the columns. The round function will round the CLH column, and the propcase function will convert all city names into proper case in the city column. Below the from clause, I'm joining the home equity table with the bad lookup table using the bad column in each table. After the query to create the table is executed, I'll add another query to query 10 rows. Within the SQL code cell, you can add multiple SQL statements separated by a semicolon. I'll execute the cell to create and preview the final table. The results show a preview of this final table. I'll navigate to the SAS libraries and confirm the new home equity final table was created. If you are new to SAS, the work library is a temporary library, and every table in the library is deleted when SAS is closed. To permanently save a table, use another library. To confirm all missing values were replaced, I'll execute one last query to count the number of missing values in the mort due and value columns. As expected, all missing values were replaced. That's it. That was a quick introduction into executing SAS SQL in SAS via Workbench. I showed familiar ANSI standard SQL syntax, as well as some SAS enhancements like the calculated keyword, SAS formats and labels, and SAS macro variables. The SQL procedure in SAS has much more functionality than discussed here. Check out the SAS documentation for more information.